Hi everyone, this is 8th grade Elevate, and for lesson 46, students will be recognizing and creating equivalent expressions. So you are going to spend about 2 minutes on this teacher intro here, letting students know that today they will be writing equivalent expressions by combining like terms, right? And so they give you the example of 3x plus 5x minus 2x. What you will have to explain to students is that these are like terms because they all have a coefficient attached to the variable x. Because they all have x, this means that they are a like term. And so all we then have to focus on is combining the coefficients, right? So 3x plus 5x is 8x. Then we are taking away 2 of those x's. 8 minus 2 gives me a total of 6x. Remind students that x is just a variable, and so something that I like to do with students who are struggling is plugging in a word for that variable. So if I have 3 xylophones and then I add 5 more xylophones and then I take away 2 xylophones, what do I get? They should say that you have a total of 6 xylophones. Substituting the variable for a word is sometimes helpful for kids because then they can understand if they had something like a 3x plus 5x minus 2x plus, let's say, 7a. Students will know that, okay, I can add up all of the xylophones, but I can't add an apple to that. That doesn't stand out. It's not a like term. Xylophones and apples are not the same. So that's just like a trick that you can use with students. From there, you are going to jump into a 2-minute teacher model, very similarly to the example I spoke about above. The only thing that is different is here they are actually seeing what it looks like to have 2 different terms. And so we have some apples and then we have some bananas. You cannot combine those. And so students will then see, okay, well, I can combine 2 apples plus 8 apples. And then I can also combine 2 bananas plus 4 bananas, right? Giving us a total of 10 apples and 6 bananas. Then we are going to jump into using the distributive property to factor an expression, but we are not going to spend time modeling this introduction for students. I think as the teacher, it's important for you to know that students will have to rely heavily on knowing how to use the greatest common factor in order to be able to distribute effectively. And so what you will model is question A for about 3 minutes. So it asks you, what is the greatest common factor of 6y, 30y, and 15? What is important to know is that even though students might have some experience with greatest common factor, these terms are also attached to variables, and so 6y means 6 times y, meaning that y is also a factor of 6y. So when you are listing out the factors of 6y, you need to include that y, right? And we know that we have all the factors of 6 because 1 times 6 is 6, and then 2 times 3 is 6. Same thing for 30y. That means 30 times y, so y needs to also be included as one of your factors. And we know that we have all the factors because 1 times 30 gives me 30, 2 times 15 gives me 30, 3 times 10 gives me 30, and then lastly 5 times 6 gives me 30. okay? And then the last one that they ask for are the factors of 15. And so notice that 15 is not attached to any variable. And so because of that, we are not going to include any variable. We're just going to factor like normal. And so we know that 1 times 15 gives me 15, and 3 times 5 gives me 15. They have several different numbers in common. Actually, 2 should not have been highlighted because they all don't have 2 in common. But all these 3 terms have 1 in common and they have 3 in common. One question that you want to ask students is what factors do they have in common? Students should be able to say they have both 1 and 3 in common. Then you ask them, okay, well, based on the 1 and the 3, which of these is the greatest factor they have in common? What is the greatest common factor? Students should then be able to identify 3 as the greatest common factor. Then you will jump into another model showing students how to utilize the distributive property. Students will learn that they have to multiply what is outside of the parentheses with every term that is inside of the parentheses, right? So 2 times 5x gives me 10x, and then 2 times 7 gives me 14. The last model that you are going to do is around the distributive property as well, so taking on what we did up here. However, there's also a piece where we are trying to add more terms to what we've already distributed to then figure out whether it is equivalent to another expression. And so we're going to do the same thing. 4 times x gives me 4x, and then 4 times 2 gives me 8. So I have 4x plus 8. I have 4x plus 8. I need to then add the 4x plus 8 to 3x plus 7. So this is what I talked about earlier. We're finding like terms, right? And so we have 4 xylophones plus 8 plus 3 xylophones plus 7, right? We have some xylophones and then we have some whole numbers. Whole numbers cannot be combined with variables. And so we need to combine our xylophones. 4x plus 3x gives us 7x, and then combine our whole numbers. 8 plus 7 gives me 15. Making my expression on the left-hand side 7x plus 15. They want to know whether 7x plus 15 is equivalent to 7x plus 14. No, because 14 and 15 are 2 different numbers, so they are not equivalent expressions. From there, you'll launch students into a turn and talk around error analysis. They want to know whether Lana distributed this correctly because she got 3x minus 15. And then we will launch students into 8 minutes of practice time where they are distributing to write equivalent expressions, combining like terms, determining if the following pairs are equivalent. Then they'll do some work around greatest common factor and factoring. Still for the 8 minutes. It shouldn't take that much time. And then jumping into 5 minutes of their exit ticket for a total of 4 points.